Hello, everyone. Welcome back. Today we're going to be talking about the operations of algebraic vectors in 2 space or in R2. Just a reminder, we've already talked about just general vectors in 2 space, so that was the previous lesson. So make sure you watch that if you haven't already. With that said, let's get going on this one. So here it says to draw the position vectors a, which is 5, 3, and b, which is negative 4, 2, on the xy plane. Okay, so let's do that. Let's go ahead and do that. I'm going to start here, and I'm going to say, well, position vector A would be 5, 3, so 5 to the right and 3 up, so here. And then that's going to be A. So this whole vector would be OA, right, from our origin to A, OA. And then we have B, right? So B is going to be negative 4 and up 2, so it's going to be right there. So there's our vector OB. Okay, so there we have it. Today I'm also going to introduce some standard vectors. So there's unit standard vectors that are I and J, and what I represents, let's use a different color for this. What I represents is it just represents one space to the right, okay? And then J represents one space up, right? So every time we go, we have an X coordinate, that has to do with I, right? Because whenever we go, we have an I. For every I we have, we move right one, right? And then for every time we go up, we move J one. Now, let's say we wanted to go left or down, we would just use the negatives of these vectors, right? So if I see negative 5i, that means we went left 5, or negative 3j, it means we went down 3, okay? So basically, we can write these vectors using the standard vector notation by saying that OA, which is 5 from the origin up to 5, 3, is the same as 5i plus 3j. Or likewise for OB, we can say this is the same as negative 4i plus 2j. Okay, and there we have it. That's what we can do there. All right, now the next one is asking us to find the magnitude of OA. So recall, how do we find the magnitude? Well, the thing is, this is a hypotenuse in 2 space, essentially, right? So if we look at it this way, we can recognize something here, which is that this is really just 3, and this is really just 5. So using Pythagoras' theorem, we can say that a squared plus b squared is c squared. So magnitude of OA would be the square root of 5 squared plus 3 squared using Pythagoras' theorem. Now, there are some grade 9 lessons about Pythagoras' theorem. So if you're unfamiliar or you just want to review the concept, you can go watch those. But that's all I'll say on it here. Okay, so this is equal to what? This is equal to 25 plus 9, which is equal to root 34. So therefore, the magnitude is root 34, which comes out to about 5.83 or so. Okay, so the magnitude or the distance of 5.83 is going to be, of OA is 5.83. Now they're asking us to find the distance for OB. So it's going to be the exact same, except here we have negative 4 and 2, right? So this is going to be equal to our square root of negative 4 squared plus 2 squared. That's going to be root 16 plus 4, which is root 20, which is about 4.47. So this was a little bit shorter, which we expected as much. It looks a bit shorter, so that's about right. And so there we go. There we go. So there's our magnitude for both of them. There's how we would find that. Just a reminder, use Pythagoras' theorem and we'll be good. Okay, next one, part E, says to find A plus B, right? Which is OA plus OB. So let's do that. Let's do that. We can actually use the unit vectors that we had earlier. So reminder, unit vectors were up here. The unit vector ways that we express these. And we can say, okay, well, if we want to find a plus b, all we have to do is find 5I plus 3j, which is a, plus negative 4I plus 2j for b. And then let's do that. Here we get 5I plus 3j minus 4I plus 2j, right? So therefore we just get I plus 5j. And there we go. All we had to do is add up some basic numbers and we had it. Okay, now how would we find the magnitude of a plus b? So keep in mind a plus b is this, which is the same as 1 comma 5, right? If we just convert that quickly, it's just the coefficients. So to do that, we would say this is the square root of 1 squared plus 5 squared, which is equal to the square root of 26, which is about 5.1. It's just a little more than 5. So that's what that one would be. Now we're going to do something extremely similar next when we find the subtraction of them. So I encourage you to pause and try to find that right here, right now, because it's extremely similar to what we just did. Okay, so let's do it. Let's do that. Okay, let's continue. So here we have 5I plus 3j, and then we have minus negative 4I plus 2j. This time we're subtracting it. So here we have 5I plus 4I plus 3j minus 2j, right? So here we have 9I plus j, like that. Okay? So therefore, that's the same as 9 comma 1. So that this is going to be root 9 squared plus 1 squared, which is root 82, which is going to be just a little bit greater than 9, right? So there's our magnitude. Okay? All right, so now they're asking us to find AB, right? Which is the same as OB minus OA or B minus A. So let's do that. Let's find B minus A. So that would be negative 4I plus 2j, subtracting 5I plus 3j. So what are we going to get here? We're going to get negative 4I minus 5I plus 2j minus 3j equals negative 9I minus j, like that. So therefore, we have negative 9 and negative 1 as our point, right? Now, in terms of finding our magnitude, our magnitude is actually going to be the same as the last one because these values will get squared, and then we end up with root 82, which is the same as 9.06, and there we have it. Very good. All right, very good work. Well, there we have it. All right, and let's do one more example here. This example says for vector x being the same as 3I plus 2j, and y being the same as negative 4I plus 5j, find 2x plus 4y, and then find the magnitude of 2x plus 4y. So how would we do this? We're going to say, well, let's do 2 times x, which is 3I, plus 2j, plus 4y, which y is negative 4I, plus 5j. Now, one of the properties of vectors is the distributive property. So we can distribute these, and in fact, we should distribute these and then simplify. So let's do that. So 6I plus 4j minus 16I plus 20j, right? Another characteristic said we could rearrange the order of them, which means we can collect like terms. So we're going to get negative 10I plus 24j j. So that's going to be negative 10 comma 24. So now all we have to do is find the magnitude of that. So that's going to be equal to negative 10 squared plus 24 squared, which is equal to 100 plus 576, which is equal to root of 676. Oh, which actually is a perfect square. That's going to get us actually 26, I believe. If I'm doing the mental math right, 26 it should be. So there we have it. We actually got a nice round number for once for one of these. But yeah, so that's an example of how we can do these things in two space. So basically, what we do is we take things, we put them into their unit vectors, and then we use those unit vectors, those coefficients, in order to apply the Pythagoras' theorem in an algebraic manner. And then from there, we can say, we can plug those into Pythagoras' theorem and say, here's our magnitude. So there we have it. All right, well, that's everything for vectors in 2 space. Next time we'll talk about operations of vectors in 3 space, so we'll see everyone for that. Bye, everyone.